Okay, hello everyone. I hope you can all hear me despite of my fairly evident Italian accent. So, the talk of today is titled How We Went from Zero to DevOps, the Camunda Journey. You know, when I started thinking about this presentation, when I started thinking about how to prepare my slide, I asked myself a question. If I would have to summarize the DevOps movement, culture, philosophy, however you want to call it, in just a couple of words, which word would I choose? The DevOps movement is so big. I mean, there are containers, there is configuration management, and it's so difficult to find a unique summary about all this thing. But eventually, I mean, asking feedback from colleagues, looking around in several blog posts, I think I found the perfect way to describe our movement. What I think is that DevOps is all about continuous improvement. We are a community of computer scientists, of computer engineers, of computer nerds sometimes, that basically understands that not everybody does the thing the same way. We are aware that different companies might have different needs, that different companies might need different tools to achieve their objectives. And this is why, in the last years, I don't know if you realize that, but we built so many different tools. So many different tools to make our job easier. There are containers, there is configuration management, there is continuous delivery, continuous deployment. And this is just a small section of what DevOps has achieved in the past years. On the other hand, what this makes is it creates quite a bit of confusion, you know. Just think about somebody who just exited from university yesterday and comes to you and says, hey, I would love to approach the DevOps world. Where should you start? Should you start directly from containers? Starting with deploying his blog on Kubernetes? Or would you start with something simpler, with configuration management? Most of these tools are really valuable in our companies. And some of these, not everybody realized it, even do the same thing. This is because we realized that different tools have different purposes. There is no one unique way of doing things. We use different tools based on our needs. And it's really not something rare, finding online a blog post of company number 1 that switched from software A to B because B is so much better, and finding company 2 switching from software B to A because A is just amazing, no? This is what created in the past years a bit of confusion around the DevOps movement. This is a conversation that I found in the AWS support channel that just made me laugh so much and summarize this concept so easily. This guy is like, hey guys, I'm sorry, I've been offline for a couple of weeks. What's the new trend? What is all about right now? I should get updates. Being offline, even for a short period of time in the DevOps movement, means being lost really, really fast. This talk, the talk we're having today, is about a journey. The journey of how we went from a company that had no experience whatsoever in infrastructure and infrastructure management to having a completely automated infrastructure with continuous delivery, continuous testing, and continuous deployment in some cases. It all starts like all the journeys with the famous sentence, once upon a time. Once upon a time, me, Andrea Giardinia, I'm a DevOps engineer, I started working for Camunda, halfway through this process transitioning from no infrastructure to automated infrastructure. Camunda is a company based in Berlin that makes something very particular. It makes a software for business process management. Basically, what our software allows you to do is to organize your work processes using some diagrams. Basically, you have different notations that you can use to make your workflow easy, understandable, clear, and explicit to everybody. And I mean it, for our clients, it works really, really well. Basically, you have your own model or your own machine. You can save these diagrams. You can send it to your colleagues through email. The colleague replies to you with some reviews, and then you can continue editing this diagram until you get the perfect version. But around 1 year ago, we thought, okay, this is nice. It works really great. But it was time for something new. It was time for something different. I mean, we wanted people to be able to collaborate on the same diagram, to work on them, to connect through them online. We wanted to create a platform where users would be able to write their diagrams there, share them with their colleagues, comment on them, create threads, discussion, export the diagram as an image if they wanted, all in the cloud. This is when the Kawimo project started. Kawimo stands for the Camunda Web Modeler. And for us, it was really a big challenge. I mean, we are a Java-based company. We make this Camunda modeler with Java. And this was for us the first time that we tried to achieve a software as a service offer. And for us, it was really complicated because, eventually we realized that really nobody in our company was really skilled on that sense. Most of my colleagues are Java and JavaScript developers, and I can assure you that they are able to do the worst Java black magic, but none of them knows much about configuration management. None of them knows about infrastructure much. And this is why we have to start from the scratch. We had to start from zero and grow until we achieved what we attain today. And I mean, ideally, when you think about it, okay, I will just read a couple of blog posts, copy-paste stuff together, and everything will just work out of the box. Eventually, we realized that the path from no operations at all to DevOps, we ideally thought it was like this. Unfortunately, is way more something like this. So you go up, you go down, sometimes you fail, sometimes you roll back, sometimes you do the same thing twice, just because you didn't get them properly the first time. And this is what we need to understand, is that this is completely fair. This is completely fine. Nobody, almost nobody, gets the things right at the first time. It's fine to redo things. It's fine to change direction while you are doing a process. The important thing is that you need to realize when you're doing something wrong and realize it soon, as early as you can during this process. So we started. We were super excited about this new project. Our developers already started coding some code for this application. But we started, first of all, sitting on a table all together, defining priorities. What we want to achieve now, as soon as possible. What we want to achieve in the short term, and what we want to achieve on the long term. Something that will give us priorities. It's all about defining your priorities and decide what you want to achieve now and what you want to achieve later. And have a small focus all the time. So what we decided eventually is that what we wanted to achieve now is that we wanted something working and we wanted to have it soon. We didn't think from the beginning about reliability, scalability, high availability. We just wanted something working and working now. Our developers were already writing the website, and they needed some basic infrastructure to support them. We wanted to have some basic automation, nothing crazy. We wanted to have something able to deploy our application whenever our developers were pushing something to master, something really easy. And what we decided to do is that since we wanted to do this process fast, we needed to rely on previous experiences. If any of our colleagues had any experience with a software, in this case, we had to use that experience to make our work go faster. And that's how it started. First steps. First steps, when you think about an infrastructure, you need, of course, a cloud provider. In our case, we chose AWS from the beginning. Why, you would say? There is not a clear answer about that. Some people had already experienced on it. We already had our services in that. Moreover, we knew that if we wanted to make things more complex in the future, if we wanted to add load balancer, microservices, containers, we would have made it. I mean, AWS offers you all this possibility. You just need to learn how to use them and how to configure them. After that, continuous integration. As I said before, we're a Java-based company. We have really a lot of experience in Jenkins in our CI. Our CI is running thousands of jobs a day because basically our Camunda modeler is supported for different versions of databases, different web services, and it has like different lifetime. So every time we deploy a new version, we have to test it in all this combination of web server, database server, and application server. And this now, it was a step out of the blue. We had to get out of our comfort zone and try something new that we never tried before. What about server infrastructure and configuration? We had no experience at all about that. We had to start, ask around if somebody had some experience before, and based on that, build our infrastructure. We decided to do eventually this combination, to use this combination of Terraform and Ansible. Terraform is a software that basically allows you to define your infrastructure, your server, how they are connected to each other using code. And believe me, in the beginning, when you start using Ansible and you start using Terraform and you start to use it for like a personal project, everything looks very easy. But when you start to go to a scale, things change. And we learned that the hard way that we needed separate Terraform state file for each one of our environment. We needed the hard way that Terraform really allows you to do everything, but your code needs to be structured in an appropriate way if you want to bring it and make it portable in different environments. After that, eventually, we started building our infrastructure. All the servers are up and running, but we needed to find a way to configure them. And even in this case, this step took a bit longer. We started evaluating different configuration management systems. We started working with Puppet and Ansible. Eventually, at the end, we decided to go with Ansible for a simple reason. Somebody already used it, first of all, and I find Ansible easier to understand for a first-time user. The Ansible playbook are way easier to read, in my opinion, compared to the Puppet manifest. On the other hand, I also worked with Puppet in the past, and I have to admit that the state management is really, really good. So even here, not always there is a good reply to what you need. Sometimes you just have to start writing down things. Start testing and roll back if you think that things doesn't work. Unfortunately, this thing doesn't work. I mean, something was missing. Terraform and Ansible were completely unaware of each other. They were not able to talk to each other. So whenever we wanted a new machine, whenever you want to spawn a new server, we had before to change the code in Terraform, run Terraform apply, wait for a server to be up, go in the AWS console, grab the IP and put it inside the inventory file of Ansible, run Ansible again. This process is completely manual. It's completely error-prone in any way. It's really, really easy to mess up things. And we couldn't wait 15 minutes every time we wanted to set up a new server. Because as most of you probably know, configuration management systems are really fast in the consecutive run. But on the first run, when the management system has to configure basically everything, it might take a while. This is why we decided that we needed to change something. We wanted to make Terraform and Ansible aware of each other, let them talk to each other. If you work with AWS, you probably know that whenever you define an EC2 instance, you are able to define different tags. Different tags allow you to specify a sort of key value store to these instances. We decided in our case to define two tags. One tag is called environment, that would specify if the machine was part of staging or production, let's say. And one tag called role, which would specify if the machine is a database server, web application server, it's a load balancer. What happens after that is that using a feature by Ansible called dynamic inventories, Ansible is able to group these servers based on the same tag. So all the machines that had environment equal to stage were grouped by Ansible inside the same group. All the machines with role equal to web server were grouped in another group. And Ansible understands that whenever the machines have the same tags, they need to be configured in the same way. In this way, from Terraform, we can specify the tags and say, I want this machine to be a staging machine, web server. And Ansible automatically adds the machine to the staging server and configures it accordingly, based on the parameter that you define for the stage environment and for the web application. I'm going to explain that in a more graphical way to make things more clear. So imagine the first tag, environment. As I said, production and stage, okay? You can have as many as you want. You just need to define the different value for this label, basically. So imagine them as two horizontal groups like this. The second label is called role. In this case, it's a different label. So we're talking about vertical groups. So in this case, I just use an example, two different groups, just application server and database server. This group, they cross, as you see. Whenever you specify role equal to app, you get the servers that are application server, but of the staging environment and the production environment. Same thing when you say stage, you get all the servers in stage. What if you want to run something like more defined? What if you want to limit the Ansible run? What you can use in this case is Ansible operator for intersection. So let's say that you want to run in all the prod server, you just specify limit equal to prod. If I want to run in a subset of this machine, I use the intersection operator. Like in this example, all the application servers that are part of the stage environment. Stage, column, equal app. In this case, Ansible will know automatically that it has to run in all the application server, part of the staging environment, and just on that. Eventually, this code was quite fine and worked quite well, but what if we wanted to do something more specific? What if we wanted to create a sort of hierarchy of servers, and hierarchy of roles? So, in our case, we had some maintenance host. Maintenance host is basically application server. They are basically identical. But on top of that, we had an extra variable that triggers the maintenance mode in our application. Why did I draw this maintenance inside the app? Because the configuration of a maintenance node is exactly the same as an application server. It just has an extra variable that triggers this maintenance mode. And this is the concept of sub-roles that we introduced. Maintenance is a sub-role of app because the configuration of maintenance is the same of app, but slightly more specific. What happens if I want to run something in the maintenance node? All I have to specify is something like this: stage :end app underscore maintenance. The underscore character in our case defines that maintenance is a sub-role of app. That maintenance is a subset of the application server in app, and there's a more specific configuration about it. This eventually was working fine. I mean, now we reduced a lot of steps. We didn't have to copy-paste IPs from the AWS console anymore, but still, something was not right. Something was not okay. We started thinking, okay, what if we receive like a spike of traffic? We cannot handle things like this. It's still way faster than before, but it's not automated. We wanted to be able to scale up and down automatically, without user interaction, without running Terraform apply and Ansible playbook all the time. Eventually, this in our case required a strategy change. We started using this feature by AWS called the autoscaling group. Autoscaling group in AWS allow you to scale up and down your server in a dynamic way. It's basically a logical abstraction. It's a group that includes inside more servers, and based on some triggers, for example, in our case, we use CloudWatch alarm, you can tell him add one more server to this group, or destroy one server. You can say things like, if the CPU usage of my autoscaling group is over 80%, spawn a new server. If the CPU usage is less than 20%, maybe you want to destroy a server and save money. This works, but it requires some changes on our side. Everything was not as easy as before. We couldn't wait for Ansible to do all the first run. And then we said, well, if it's the first run that takes most of the time, why don't we do it once? We started using this software called Packer. Packer basically is a tool that allows you to spawn an EC2 machine on the AWS cloud. It configures it using the playbook that we already wrote, so we didn't have to change not even a single line on our playbook. And after that, as soon as the machine is configured, Packer takes a snapshot of the machine and makes it available to you as an AMI. So you have your image of the machine, completely configured, ready, out of the box. You just link it to an autoscaling group, and the autoscaling group that knows that whenever it has to create a new machine, it will use that image as a reference. This made us scale up and down really easily. And the fact that we didn't have to change any code in the Ansible playbook made us also this transition quite fast. It took us some time to figure out correctly how to do monitoring and logging whenever you start to having like this machine spawning up and down all the time. But eventually we got it right. What also comes out of the box with this, which was really amazing in our case, that we got zero downtime deployment. Basically what happens is that if you use AWS, you probably know that you can link autoscaling group to a load balancer. A load balancer in AWS, they work basically this way. So you have a load balancer that routes requests to the server that you have in your autoscaling group. Load balancer constantly checks if your application is alive. If the application is alive and responds well, then your server is marked as healthy. Otherwise, if your application is not running, if it crashed, it's marked as unhealthy. Load balancer route requests only to hosts that are marked as healthy, where the application is running. So what we did, whenever we wanted to create new server or launch new application, we have a Jenkins job that basically, one by one, marks all the application servers as unhealthy. What happens after that? So the Jenkins job starts. First server is marked as unhealthy. As soon as the load balancer notices that, stops immediately to route requests to it. It lets all the connections that are already active to drain, of course, because you don't want to cut the connection to one of your users, but it stops routing new requests and waits for it to drain. And as soon as all the connections are drained, the machine is destroyed. What happens at the same time is that the autoscaling group notices that one of the machines is unhealthy and starts spawning up a new machine based on the AMI that I created before with Packer and I assigned to the autoscaling group. The machine, of course, at the beginning is marked as unhealthy because it's booting up and the application is starting and everything. But as soon as the application starts to reply to the request of the load balancer, then the load balancer marks it as healthy and starts routing requests to it. And this is what happens every time we deploy to production. We don't need to reboot for security updates. We just need to recreate the whole cluster. And in our case, what happens is that our users can continue to play on our website without noticing anything, without noticing that we are basically destroying the whole cluster in the back. And this is really cool. This works really well in our case. It made us like going from zero to something deployed and automated and scalable. We didn't think that we could reach this point, but eventually we made it, and we are proud that we did it through this incremental process. But most important thing is also lesson learned. What did we learn during this process? The first thing is that the DevOps path is not straight, as I said in the beginning. If you are imagining that going from zero to full automation in a straight line, you are wrong. The DevOps path is all about finding alternatives, testing different tools, testing different approaches, and testing different software in combinations between them. There is no one unique solution to go to have everything automated. What we realized as well is that sometimes you might have to rethink your implementation, and this is totally fine. It's totally fine if the implementation that you thought it was good in the beginning is not good afterwards. Don't take it as a failure, never. Reimplementing is never a failure. Reimplementing is always learning. Is also what is our community all about. We're a community of people that likes learning. Otherwise, we wouldn't be here. Our world moves so fast that we always need to keep up to date with what is happening. Eventually, at this point, stage and production were quite okay. We're working fine. We still had our problem. I mean, what about the operations environment? What about the tools that support all this thing? How did you handle them? So, since the beginning, we started using Docker registry. So, we are using Docker since a really long time. In our CI, we use Docker since a very long time because, as I said before, we need to test our modeler with different version of database, different version of web server, and doing that without container is just impossible. We need to have a machine with a database, 7.1, 7.2, 7.3, and the same for a web server. This becomes a nightmare. But with Docker, everything works really well. It works really well out of the box. So whenever we started creating this new infrastructure, we decided from the beginning, let's do it the Docker way. Let's start implementing everything with Docker. At this point, we needed, of course, a way to store our images. This is why the first service in our ops environment was the Docker registry. And it's fine. I mean, in the beginning, you are in a rush. You're just creating stuff, moving things very fast, and you just set up a Docker registry and forget about it. Docker registry on an EC2 machine with local storage. You see the problem, I guess. So at this point, we thought, okay, good. I mean, we have autoscaling group. They work really well. What happens if one of the availability zone goes down? Well, okay, the autoscaling group will notice it, will spawn a new image. The new image will try to check if there is any application update, because maybe it has been rebuilt like one day before and now the application is different. What if the Docker registry is in the availability zone that goes down? I mean, it's the end. We decided at this point to change and to make also Docker registry highly available, to put it as well in an autoscaling group of fixed size in this case. We have a size of 2, minimum and maximum size of 2. So we have like 2 machines in different availability zone behind the load balancer, and they both have an S3 bucket as a backend. They both point to the same S3 bucket. Basically, they store all the image layers, all the metadata in the same bucket, and whenever you make a request, you don't know if you end up on the machine A or machine B. But the important thing is that they all have the same resources. You can always pull and push from them, and you get this image from the S3 bucket directly. This works really well in our case. It's super fast, and it's really, the Docker registry has done a really good job integrating with the S3 bucket. eventually, during this migration, while we migrated from local storage to S3 bucket, we noticed something weird in our Docker registry. I mean, there were a lot of like images, tags we had no reference about. I mean, there were images that we never used before. There were tags that we have never seen before. And we said, okay, but I mean, what is happening? How comes these images are there? What we didn't realize, what we didn't think about actually up to that point, is that basically in our infrastructure, everybody was able to pull and push. As soon as you were logged in with your credentials, you were able to pull and push whatever you wanted. And this is fine if you use it properly, but if developers pushed a test image or a test tag, they were not removing it, they were just forgetting about it. This is why they decided to become a bit more strict. This is when we decided that we should have a central authority that builds images. In our case right now, the developers are able to pull all the images they want, but whenever they want to build something and they want to push it to the Docker registry, they have to do it through Jenkins. Sorry. Basically, Jenkins, in our case, is the ultimate authority. Everything that is being built using tags or images has to pass through Jenkins. This helps us keeping logs of what is happening. This helps us keeping track of which changes caused which image creation, which changes caused a tag creation. And we wouldn't have been able to do that if we wouldn't have enforced this policy. It's a bit annoying for our developers as well, sometimes, I have to admit that. But on the other hand, it's the only way for us to understand who built what and for which cause. Even in this case, what did we learn? It's always about learning. The first thing is that fully knowing the feature of a software requires time. In the beginning, we didn't even know that the Docker registry had this mechanism to have S3 as a backend. We were just thinking, okay, let's just set it up and that's it. We will think about it later. You might not have the time to actually look at this thing. Looking at all the details of a software requires time. And in the beginning, where your priorities are getting up and running soon, you might not have the time to do that. Adapt your infrastructure to fit your needs. Everyone has different infrastructure. Everyone has different needs. You don't need sometimes to think about scaling from the beginning. If this delays your process of months because you want scaling, maybe you want to implement a solution right now and think about scaling after. Of course, you always need to do the thing the proper way, because in some cases, if you don't implement scaling, then it might become very difficult to go at scale. But if you do the things properly from the beginning, like we did choosing Ansible instead of Bash script, then the transition comes easier. And you can do it whenever you want, as soon as you have time, as soon as reliability and fault tolerance becomes your priority. What about Jenkins? Jenkins, as I said before, was the core of our process. So we started like creating Jenkins job to deploy the application, test the branches, package Docker containers, running backup script, cleanup script, and what we obtained was a very angry Jenkins. Our Jenkins was just overloaded, and we realized at a certain point that whenever our application was building, we were not able to trigger backups. This is not the good way of doing things. This is not the good way to do. So what we decided eventually was to decouple Jenkins. Go from one Jenkins that was running everything to two different Jenkins, running each one is its own scope. We had one Jenkins running all the application-related tasks like performance test, database building of the application, building of the branches, testing for our developers, and another Jenkins that was dedicated to infrastructure, that was running backup, deployment, cleanup script. Whenever the application Jenkins needed to do a deployment, let's say, it always has to call the infrastructure Jenkins to trigger the deployment. In this case, what really helped us was writing all the jobs with job DSL. How many people use job DSL here? Lucky one. This process would have been a nightmare without job DSL. Job DSL is a very nice Jenkins plugin that basically allows you to define all your jobs and to define all the work that the Jenkins does through code. In this way, we just had to split our job DSL files in two different repositories. Then you just point Jenkins at it, and Jenkins automatically configures all the jobs. You get a fully configured Jenkins with all your jobs there, your credentials in there, just writing this job DSL file. And it also, since you can put it, of course, in a Git repository, You can version it, so you can see how your jobs evolved. You can see if something went wrong, if there is a change that caused it. What did we learn from that? Some services grow slow. We never thought at the beginning that Jenkins would have been a problem, But eventually, when things start to grow, you start to overload it. At a certain point, you need to scale. You need to move things out. But yeah, scaling is not needed from the beginning for services like this. Scale whenever you need it. Scale whenever you, if your focus is getting the application up and running as soon as you can. Scaling is something that you might have to postpone. You always have to do things in a clever way, in a way that whenever you want to implement scaling, you just do it. And you don't have to refactor the whole thing. But of course, you always need to focus, first of all, on your priorities and on your objectives. Logging and monitoring, another big topic whenever I'm in a DevOps conference. Basically, even in this case, we were going completely out in the blue. We have some basic monitoring for our CI, nothing complicated, nothing crazy. And so we started looking online like everybody would do. What should we implement for monitoring? The trend at the time was, and even now I would say, is the ELK stack. Classic ELK stack. Logstash, Elasticsearch, Kibana. Works really great for us. It has a very good community. It works very nice whenever you spawn and destroy machines. And it has very good integration with AWS. Do you remember the tags I talked about in the beginning, the tags that you define in Terraform? So whenever you spawn an Elasticsearch cluster, you can add a plugin that basically is called EC2 Discovery. And basically you can tell to the Elasticsearch server spawns up, look, all the members of your cluster are the EC2 machine with a role equal to Elasticsearch. Out of the box, out-of-the-box service discovery for Elasticsearch. With just one plugin, we are able to store our snapshot in S3 bucket and make backups this way. At this point as well, we had to think what's about logging. And most of you might think, okay, if you already implemented the ELK stack basically for logging, why don't you use that also for monitoring? You just straight out of the box. We decided indeed to go in a different way. We decided to use a different software that has been becoming more and more popular lately, which is called Prometheus. If you never use Prometheus, I have to admit that the first approach might be a bit difficult. It has a completely different approach to monitoring. So basically, when you think about a monitoring system, you think about a server, basically a machine that you want to monitor. You install on it a client. This client collects all the metrics and pushes them to the monitoring service. Prometheus works exactly the opposite. So you have a Prometheus server, which is the server for monitoring. You specify a set of targets, and then Prometheus collects metrics from these targets. So all your machine basically exposes a simple HTTP server that exposes a list of metrics, and Prometheus grabs this metric periodically from the list of targets. What is really cool about Prometheus is it has as well AWS service discovery. So we can say, apply all the normal checks like CPU, memory, storage to all the machines that I have inside my AWS account. And it will do it out of the box. You don't need to specify the URL anymore. Even more cool, what it allows us to do is always using the tags that I defined at the beginning. If a machine has role equal to Elastic, then apply all the common checks, of course. Moreover, also grab the metrics for the Elasticsearch server, and we get monitoring for Elasticsearch Jenkins out of the box. Simply specifying the tag. If the tag is equal to Jenkins, you grab all the monitoring for all the metrics for Jenkins as well. If the tag is equal to Elastic, you grab also the monitoring for Elastic. If the tag is equal to app, it means that in the application server, it's exposing metrics on that port. So more than CPU, storage, and memory also get those metrics. This works really, really well in Prometheus, made our life so easy. We don't have to change the configuration all the time to include new server. Everything comes out of the box with the service discovery feature of Prometheus. What did we learn in this case? That logging and monitoring, first of all, are fundamental. You need to take care of your logging and monitoring. Whenever you have an application that goes down and you don't know what is happening, basically it's the end. I mean, you cannot do anything. You don't understand what's the problem. You don't understand what's the cause. And there is no way to do it if you don't get the proper metrics, if you don't get a valuable metrics, and if you don't display them in the correct way. Because this is also a pattern, something that is difficult. Knowing which metrics matters, which metrics don't too much, and display them in the correct way. Different solution for different needs. We could have just used Elasticsearch, and put everything in there, monitoring, logging, and that's it. But sometimes what you want is finding a solution that is the best of breed, meaning that you may want a solution or use a software that is actually meant to be used for that. Elasticsearch works great also for monitoring, but it was born as a logging software. And then at a certain point it evolved into monitoring. Prometheus has been a monitoring tool since the beginning. They are really focused on monitoring. And so you might want to use these alternatives sometimes and differentiate the things that you use. Now the big topic. Nobody likes this topic at this conference. I'm joking, of course. But security, whenever you have servers pointing up and down and moving around, is always a different topic. It's a difficult task to accomplish. It's something difficult to obtain. And there are some techniques that we learned along the way that might be useful to you. Since the beginning, when we met at this table defining our priorities, we said, okay, security, let's talk about it for a second. First thing, very strict security group policy. This is the first thing that we do. All our machines in our AWS account are able to talk one-to-one. Server A speaks to server B, if he needs to, on that port and that port only. Our environment is very strict. If we have an intruder, let's say, he wouldn't be able to see all the machines. He will have also only a limited scope based on the machine he managed to enter, and also he will be able to go to connect to other machine only on a set of ports. Only on the ports that we said that were good, because whitelisting, as you know, is always better than blacklisting. Making things available whenever you decide is always better than exclude services that are not needed. Eventually at this point we said, okay, what we can improve even more from this point of view? We have containers. What about the containers vulnerability scanner? We started having a look at this project called the Claire. It's a project by CoreOS. Basically, it's a container vulnerability scanner. You submit the container that you want to scan, and Claire, one by one, checks each layer for known vulnerabilities. It basically parses the vulnerability DB from the most common distribution, like Ubuntu, Alpine Linux, etc., and then, based on that, it tells you if your containers are actually vulnerable. This came as a surprise to us. So the first time we ran Claire, we saw some images that were vulnerable to vulnerabilities that were fixed months ago. And we were thinking immediately, how this is possible? This image is built 10 times a day, maybe. How is it possible that there are vulnerabilities that were fixed 6 months ago that are still there? Doesn't make any sense. Actually, if you think about that, it makes a lot of sense. If you know how Docker builds containers, basically Docker uses different layers, okay? So let's say that you have an image with different layers 1, 2, 3. You usually have in your Docker file your application as the last line of the Docker file. What happens is that whenever you modify the application, Docker, instead of rebuilding the whole set of layers, it just rebuilds the last one, and it links it with the previous 2. So you might have a layer 1 and 2 that have been built months before, without you realizing it. And that's why when we ran first Claire on our infrastructure, we found some containers that were actually vulnerable to vulnerabilities that were fixed months before. What we did after that, in order to fix this problem, is add basically a new option to our Jenkins server. And now, whenever we find that there is a vulnerability in one of our containers, we just rebuild the container with no cache option. In this case, you are telling basically Docker, don't care about the caching, just rebuild everything from scratch. Pull the image again, rebuild all the layers one by one. Because it's true that the caching feature of Docker allows us to build a machine and to build images very, very fast. But in this case, it can be risky. I really advise you to have a service like that in your infrastructure. After that, another step that we did was, okay, eventually, we're running a web application. We should have at a certain point a web vulnerability scanner. we started investigating on like the available vulnerability scanners out there. The one that we found that is most promising for us is called Arachne. Arachne is a tool that basically scans your application, your web application, tries to inject like different common like SQL injection and things like that in your application, and then it gives you a nice report telling you the vulnerability that it found. Unfortunately, Arachne is not 100% compatible with all the latest web standards, all the latest JavaScript, and so it doesn't manage to parse really all the pages of our application. Eventually, if any of you has a web vulnerability scanner that would like to suggest, I really invite you to approach me because we spent so much time on this task. What did we learn? First thing, do not underestimate the impact of security. Security is difficult. Security is not easy. And on the other hand, it's better to have security from the beginning than implementing it later. If we would have, like, in the beginning say, okay, let's just say that every machine speaks to everybody whenever it wants. I mean, yeah, it works from the beginning, and of course it makes like creating new services way more easier because you don't have to think about security. But on the other hand, if you have to do it after, if after you want to implement security, this becomes way more challenging because you have to remember, okay, so this server speaks to that one on that port, so I have to allow this. It becomes way more difficult. It's way easier to implement it from the beginning and spend a little time to have your infrastructure secured. The last one, define security practices from the beginning and make sure that all the people working on your infrastructure are using this security practice. Don't let a change go inside if it's not secure. Don't let somebody just avoid the security practice because it's lazy and because it needs something fast. Doing things fast has sense, but with security is a big topic and you don't want to have security problem afterwards. Recap. At this point, what we have right now is a completely automated production environment, completely automated and scalable stage environment, partially automated and scalable ops environment. What we are looking for in the future are different targets. We passed this first stage in which we wanted something running soon, and now we went to the second one. What do we want to have in the short term? What do we want to achieve in the short term? What we want to achieve, in our case, is first of all, reliability and fault tolerance are the main focuses. We managed to do that for production and staging. We are working on it on the ops environment. The Docker registry is already highly available and fault redundant, but other services like monitoring and logging might not be 100%. We need to think them in a different way. Keep in mind that not all your services are essential. What does it mean? So right now we are thinking, a couple of weeks ago, I got this crazy idea. Okay, what if I would have an auto-scaling group with minimum and maximum of 1? And at the beginning I thought, okay, it doesn't make sense. But then I went online and there are a lot of people actually doing that. Why? It's really easy because basically whenever you have an auto-scaling group with maximum and minimum of 1, you will always have one machine. But automatically what happens is that if your machine gets in an availability zone that goes down, the auto-scaling group automatically rebuilds the machine somewhere else. And in our case, let's say for Jenkins, everything is configured through Docker container, through job DSL. So whenever Jenkins, let's say, goes down in availability zone A, the auto-scaling group replaces it with a new instance on availability zone B. Yeah, this requires sometimes, maybe 30 seconds, 1 minute. But do you want to have like a Jenkins in cold standby all the time that is able to take the role of the actual Jenkins whenever it goes down? Probably not. Because in this case, as soon as you manage to log in your computer, you will already have another Jenkins spawned up. You will already have everything running again. You won't even notice that it was not there. Continuously improving our platform. As I said, DevOps is all about continuous improvement. It's all about making things better step by step. There is no rushing, there is no shortcut. It's always about finding alternatives, finding what's the best for your company. Not all the solutions out there are the same for everybody. There are some stack that are like sort of more mainstream than others, but even in this case, this might not be the solution that you want. What we want to do as well is splitting our application in more microservices. Right now we have one big application that does a lot of things. We would like to soon start creating small microservices, always based on container, and let the application do what the application is meant to do. Last tip, really listen to your developer need. They might be a really valuable source of input for how to improve your software, for how to improve your infrastructure, and they will let you know what your needs are. I mean, always remember that in the past, we used to be these kind of people. We were the people sitting in the basement that everybody was afraid to talk about. They were always grumpy. They were always complaining about everything. And every time a developer wanted to actually do something, every time they had to talk to them, they were basically rolling dice to decide who had to talk to them because they were so grumpy. Now everything is automated. Now we build the tools and ways to make our job easier. We made tools in order to let the machine do their job. Automate things. Doing repetitive things is a job for a machine. It's not a job for a user. In the beginning, I said that I think I found the way to define the DevOps movement in just a couple of sentences. And this way was DevOps is continuous improvement. Well, what I think I found as well is a way to define our whole mentality. Who we are, a group of people, computer engineers, computer scientists, nerds, that like to improve things, that is aware that the way of doing things is not the one that we were using before. We want to leave the old technologies in the past and make something different. We wanted to have an infrastructure automated that does things for us. Doing things the old way is not a good way. What comes out of it is this sentence. So long, and thanks for all the script. Thank you. If you have any question? Yeah?
Is there a reason you don't use Amazon ECR?
Is there a reason if we don't use Amazon ECR, the container registry? Actually, we never thought about that. We just, in the beginning when we started, we just said, okay, let's do it with a Docker registry our own way. I don't exclude that we will work on it at a certain point, because it's true that, if I have to admit, managing a Docker registry is quite a bit of work. It has no clear policy, especially on deleting images. They just pretend that you have unlimited storage. It always grows, and it's really difficult to delete stuff. But yeah, we will definitely have a look at it.
Have you tried out Docker Swarm?
Have we tried out Docker Swarm? We are using Docker Swarm in our CI right now, quite extensively. We didn't try it in this case, no. We are thinking about, eventually, this is like the next thing we will work on, doing something more elastic beanstalk. And yeah, this is a platform that we are evaluating. But yeah, I followed a very nice talk on Docker Swarm, and it's definitely something to look into, because we have the experience already inside the company, and so it might be actually easier to move our infrastructure over there, or eventually Kubernetes. Yeah.
How are you currently running your Docker containers?
What do you mean exactly?
In Amazon you got ECS, or are you running EC2 instances with Docker Engine installed?
We are running the EC2 server with Docker Engine installed and just in the container of the application, basically. In our case, on the application side, the big advantage for us is that the developers have their own environment on their own laptop, and we are just able to take the same environment and bring it to production. It's true that ECS would make things easier, but at that point I would say, why not going directly for Amazon Beanstalk? Anybody else? Yeah.
Do you think about software as a service? For example, resistance, hosting
Yeah, I mean, the thing is that it's true. I mean, managing Elasticsearch as well is a lot of effort. And the thing is that you can always say for everything, why don't you pay somebody else for doing it? But yeah, it's true. There is also Elasticsearch as a service on AWS, and it's something we looked at when we had problems with the Elasticsearch cluster. For now, we are quite good with it. We found a good configuration, so we're not evaluating it anymore. But I don't exclude that in the future, maybe it will come. Yeah.
We have two questions. The first question would be, you said you're using
Okay, yeah, so basically the question is if we're using Packer and the Docker register at the same time, and if we're packing the application inside the AMI. So basically what we do is that whenever we run, we create a new image with Packer, basically during the build process, the application is pulled from the Docker registry. So we have like application tag, stage, or testing. So let's say that you are doing for production, we have like, as soon as while the instance is configured, it will pull the app column prod. But at the same time, whenever the application will spawn up, whenever a new server will spawn up, it will check that actually the application is the latest one. So it will try to pull app column prod again, just to make sure that somebody maybe I don't know, the image you created was created way long ago. You don't want to have the same version running at the same time, the different version running at the same time. Yeah, okay, the database, he asked me how does it work at auto-scaling group with database. It doesn't work. So for database, we are using RDS. I made the example before with production and staging just like for making things more clear, but for database, we are using AWS RDS, basically. So right now we just started, so the Kawimo project is really in the first stage. We went public like last week, so we don't have anything like defined, but there are some security practices that we need to define very soon. And that's it, yeah.
How long did you take to get there? Years, months?
It took okay, if I have to, because I joined this company like during this process. So when I arrived around February, let's say, we were still at the beginning like with Terraform and Ansible without dynamic inventory. So the whole process was at the end quite fast, I have to say. But yeah, I mean, the thing is that you need to realize when you make mistake in the beginning. If people wouldn't have realized that bash scripts were not the way, I would have had to write like Ansible playbook all by myself, and this of course would have taken most of my time. But if they realized it since the beginning, and in this case this will make everything easier for us, then the transition got easier and easier. Yeah.
How many people were on this team that did this?
So right now, you mean DevOps team working on infrastructure? We are just two. We are just two, but we have our DevOps in our company, so that take care of the CI for our modeler. And basically this is really helpful for us because sometimes I don't know a technology, but somebody else does, can help me. And I mean, sometimes with computer you get stuck on the same problem for 2 days and maybe it was just a tick. And this is what doesn't happen anymore in our case because we have quite broad different experiences. And yeah, it allows us to proceed quite fast. That's it. Thank you very much.